4.6 is about writing equations of parallel and perpendicular lines. So we talked a lot in this unit about how to write equations of lines in slope-intercept form, point-slope form, and standard form. Now that we have finished 4.5, where we talk about how to identify parallel and perpendicular lines, the special cases with their slopes, now that we have that information, we can tie those two things together and we can write the equation of a line parallel to another line given a particular point, or write the equation of a line perpendicular to another line given a particular point. So how do we do this? That's our goal today. How do we write equations of parallel and perpendicular lines? Let's start with parallel lines. What do we know that's special about parallel lines? Parallel lines have the same slope. So what that means is, if you have a slope, or if you have a line that is parallel to another line, you can take the slope from that line and plug that slope into point-slope form. You can also take the point that they tell you is on your new line, so your new point, and plug that into point-slope form, because all you need to write the equation of a line is a point and a slope. If the question specifically asks you to have your answer in a particular form, then you may need to transition out of point-slope form. If it doesn't, then you can just leave your final answer in point-slope form. So let's look at this example. Write an equation of a line parallel to the given line. So here's my given line. This is my given line. Parallel to that given line with the given point. Here is my given point. Write the equation in slope-intercept form. So the only piece of information that I need from this given line is the slope. The only thing I care about in this line is the slope. So I'm going to put a box around 2. I don't care about anything else. All I need from that equation is that my slope of the line is going to be 2. Now remember, any line that's parallel to this line, y equals 2x plus 3, is also going to have a slope of 2. So I'm going to take 2, that's going to be the slope of my new line as well. I'm going to take this new point, I'm going to plug in the slope and my new point to point-slope form, which, in case you have forgotten, y minus y1 equals m times the quantity x minus x1. So y minus the y value of this point in green is -4, is going to equal the slope, which is still going to be 2 because that's the slope of the line that it's parallel to, and parallel means same slope, times x minus the x value of that point they gave us, which is 5. Now, if this question didn't ask for any particular form, you could stop right here. It does, in fact, ask for slope-intercept form, so I'm going to make myself some room. I'm going to change this to be y plus 4. I'm going to distribute over here equals 2x minus 10, and then I'm going to subtract 4 on both sides. That's going to give me y equals 2x minus 14. That is the equation of my parallel line. So something you should notice right away, they have the same slope. They should absolutely have the same slope. That's what parallel lines do. So take the slope from the line they're giving you. For parallel lines, you're going to keep that exactly the same. That is your new slope as well. For perpendicular lines, we're going to get to what you do there in just a minute. Use that slope and the point they give you to write the equation in point-slope form. So why don't you pause the video? Number 1 just asks you to write the equation in point-slope form. So take the slope from the line they give you, take the ordered pair, and write it in point-slope form. Go ahead and pause the video. So the only thing I need from this equation is the slope, which is 1/4. I'm going to write y minus the y value of the point that they gave me, which is 2, equals my slope, which is 1/4, times x minus the x value that they gave me, x minus -4. This is going to become x plus 4. And you can stop right here because the directions simply said to write the equation in point-slope form. Why don't you start number 2 in the same way? Write it in point-slope form first. Go ahead and pause the video. So you can see point-slope form here. Y minus 4 equals -2 times x times the quantity x minus 1. This question asks us for standard form. So what we need to do next is we need to distribute -2x plus 1. We need to move our constant over. Y equals -2x plus 5. And then we need to move our 2 over. Remember, in standard form, our ax plus our by equals c, so x needs to be on the other side. It needs to be positive, which it is when I add 2x to both sides, and I need to not have any fractions, which I don't. So writing the equation of a parallel line, find the slope that you need your line to be parallel to, keep it exactly the same. Find the point that passes through your new line and write it in point-slope form. If the question asks you to transition it to a different form, do that by distributing and moving variables and constants as needed. All right, let's talk about perpendicular lines. So for perpendicular lines, you're going to start in a really similar way. You're going to look at the slope in the line that you're given, but instead of keeping it exactly the same, perpendicular lines don't have the same slope. So what you're going to do is you're going to take the slope that you're given, you're going to change the sign, and you're going to take the reciprocal. So you're going to find your new slope. Then you're going to take the point that you're given, you're going to plug your new slope, which should not be the same, it should be opposite in sign and reciprocal. Take your new slope and your new point and plug them into point-slope form. And again, if the question asks you to transition it to a different form, feel free to do so. So, looking at this example in the box, my slope in my original problem is -3. I want to change the sign, so now I'm going to have a positive slope, and I want to take the reciprocal. Well, 3 over 1, the reciprocal of that is 1 over 3. So my new slope is 1 over 3. So now I have a slope, and I have a point, and that's all I need to write an equation in point-slope form. So y minus the y value of the point they gave me is 5. Is going to equal my slope 1/3 times x minus the x value they gave me. The x value they gave me is -3, so this is going to become x plus 3. This question specifically tells us slope-intercept form. So the very first thing I'm going to do is I'm going to distribute 1/3. So that's going to give me 1/3 x. 1/3 times 3, 1/3 times 3 over 1. This is just 1, 3 over 3, which is just 1. So 1/3 x plus 1. Then I'm going to subtract, or I'm going to add 5 on both sides. So y equals 1/3 x plus 6 is going to be the slope of my perpendicular line. Let's double check our slopes. Our first slope was -3. Our new slope was 1/3. Are they opposite in sign? Yes. Are they reciprocals of each other? Yes. Could I check? Yeah, multiply them. Did you get -1? You absolutely do. So let's look at a couple more examples. Go ahead and circle the slope on number 3 and write your new slope. Okay, so the slope here, the original slope is 1/2. My new slope, I'm going to change the sign, so it's going to be negative, and I'm going to take the reciprocal, which is going to give me 2 over 1, or just 2. The point that they're giving me is -3, 1. So I'm going to write this in point-slope form, and that's all it is asking me to do, is to write it in point-slope form. So y minus the y value in the ordered pair is 1 equals my new slope, -2, times x minus the x value, which is -3. So this is going to become x plus 3. And we can stop right here because that is point-slope form. Okay, number 4. Identify your slope, create your new slope, write it in point-slope form. So go ahead and pause the video and do that. And then we'll transition it to standard form together. So in point-slope form, y minus 4 equals -1/2 times the quantity x minus 1. To get this in standard form, first thing we need to do is distribute. It's going to give me -1/2 x plus 1/2. So in standard form, we're not allowed to have fractions. So right now, you could add 4 to both sides, so you would have 4.5, and then you could multiply everything by 2 to get rid of it. But I know that some of you are so uncomfortable with fractions that you would actually just be really happy to get rid of them all right now. So what I'm going to do is I'm going to multiply everything in the entire equation by 2. So that's going to make this now 2y minus 8 is going to equal -x plus 1. So basically you can think about it as if you're distributing 2 to every single piece, all 4 pieces, 1, 2, 3, 4. Now for this to be in standard form, I need all of my constants on the right, so 2y equals -x. If I add 8 to both sides, that's going to give me 9. And then I need to move x to the other side, so x plus 2y equals 9 is going to be my final answer. All right, let's look at the very last problem. Write the equation of a line using the information below. So for part A, we're going to write the equation of a line that's parallel to the line that goes through these 2 points and that passes through the point 1, 3. And it doesn't specifically tell us what form to write our answer in, so let's just leave our answers in point slope form and make our lives easier. So the very first thing we did on all of these problems was we identified the slope of the line that we're given. Well, they didn't give us a line here, but they gave us 2 points. So we can find the slope using the slope formula. y2 is 9, y1 is 5, x2 is 0, x1 is 2. That's going to give me that the original slope of my line is 4 over -2, which is -2. So for parallel, I'm going to keep that same slope. So my slope for part A is going to be -2. The point they gave me is 1, 3. So in point slope form, y minus, the y value is 3, equals the slope we just figured out is -2 times x minus the x value, and the x value here is +1. And we are done. If we had to write this in slope-intercept form, we would just distribute -2 and then add 3 to both sides. If we had to write it in standard form, we would after that then add 2x to both sides. But since this doesn't specify, I'm going to stop right here. Last question, part B. Now we're going to write an equation of the perpendicular line to the same line, passing through the same point. So I'm still going to have y minus the same y value and x minus the same x value. So y minus 3, x minus 1, this looks exactly the same as the problem above. The difference is the slope, because that's the difference between parallel and perpendicular lines. I don't want the slope to be -2 anymore. I want to change the sign, which makes it positive, and I want to take the reciprocal, which makes it 1/2. So my new equation is going to be y minus 3 equals +1/2 times the quantity x minus 1. So parallel lines, identify the slope from the line or the 2 points that they give you, keep the same slope, and use the point they give you to write the equation. Perpendicular lines, identify the slope from the two points or the line they gave you, change the sign and take the reciprocal. That gives you your perpendicular slope. Plug that slope and the point that they give you into point slope form and change forms as needed. Looking forward to supporting you more with writing equations of parallel and perpendicular lines in class. Thanks for listening.